Hey, welcome to dotnetFlix. We're here today at DotNed Saturday, and our special guest is Fanie Reynders. Welcome.
Thank you very much.
Yeah, and you're going to talk to us about some hidden gems in ASP.NET Core, right?
Yeah, that's correct.
Cool. Now, I'm very curious, so maybe you can introduce yourself and then dive into the code, because I want to see that.
Great. Yeah, my name is Fanie Reynders. I'm originally from South Africa. I'm a software architect, and I like to work with ASP.NET Core.
Who doesn't?
And exactly, .NET is the bomb. I've been doing a lot of research for talks and stuff over ASP.NET Core, the technology, but then I also gave a presentation at DotNed Saturday about the hidden gems, which I believe that's not so obvious in the framework. Yeah. One of which I can maybe show you guys on the screen is this IServer interface. People take it for granted. They have Kestrel as a server,
right?
And they just use Kestrel. But it is possible to create your own HTTP server.
Okay.
For testing purposes, they do it already by implementing IServer. But you could also implement your own IServer or implement your own HTTP server by just implementing this guy. And basically, it has a very, very simplistic interface. It has a features collection and a couple of other things like start and stop. That's basically it, as simple as it could be. So what I've done now is for the demo, I've prepared something that will take, instead of the good old Kestrel, because Kestrel's responsibility, or actually any HTTP server's responsibility, is to read from a network port the request and translate that into HTTP context for our HTTP for our middleware pipeline, right? So that's the responsibility of the server. So you can do whatever you want at start and at stop.
Okay.
The rules are, to be able to be considered as a HTTP server, you need to implement minimum request feature and a response feature.
Makes sense.
Request and response, right? So what I've done here is here's my little architecture diagram. I've got an awesome server, right? And as you can see here, it has a start and a stop function. And what it's doing underlyingly, it's actually a file-based server which looks at a folder for requests in the form of files instead of reading it from a network.
Okay, nice.
So whenever something is dropped in a certain folder, it handles that as a request, given that the contents of that file is a get space and then request that your application can understand. It parses that into a HTTP context, runs it through your middleware pipeline like normal, and then whatever your response is generated from it, the server then writes that back to a file in a output directory.
Cool.
So as you can see here, it's a little bit of a diagram how everything sits together. It's not that complex. The code I'm doing now is on GitHub.
Okay.
We'll put up a link for the guys. But let me just quickly dive in to show you how it actually works, or what the demo is. So normally when we start a application, we go .use Kestrel, or it's actually included in the default host builder, for instance. But now I've created this little helper function that's in this case it's use awesome server, and it's passing in configuration the inbox path, which is where I get my requests from, and where I want to put my responses. Right. So if we quickly F12 into that thing, this is what I was talking about. So my implementation of this is basically I'm adding a singleton. I'm basically switching out the IServer with my own one. Right, as a singleton. Now now ASP.NET Core will actually use my server as the server instead of Kestrel one. And you can do funky stuff with this.
I can imagine.
Depending on environments, you can fire up different servers for certain environments, and there's all sorts of other cool things. Now we have a process directory. These are my 3 files. One being and this is the path I was talking about. This implementation of this mechanism, I've explicitly made it the HTTP method space the request. You could do more things, and this is where the features come in. You could have your HTTP server support cookies and SSL and those kind of things, but my implementation is only supporting request, response, and also I think the servers located for dependency injections and stuff like that.
And you could use entirely different formatting here or syntax here, but then you would have to create a parser yourself.
Yes, right? so you can totally make up your own little way of maybe a CSV file or something that you interpret as a request.
Cool.
Like I said, you can, for instance, you can create an email client, an email way of saying, okay, my when my server starts up, it listens to a certain email address. This sounds very crazy, but it listens to a certain email address for requests. And then you can also say, for instance, my outbound is a certain other email address, for instance. Then literally, if you send a request to that email, and it will process it through your pipeline and send the email back, that mechanism. Nice. Do not do that in production. No. It's just a way of thinking and what you could do with the framework and how extensible ASP.NET Core is. Nice. So this is the first one. It's a normal hello endpoint. Then we have specifically one for JSON. Okay. And then we have one for an image, right? Okay. And just quickly showing how the controller looks, just to show there's no hidden
because behind this is just an ASP.NET Core request pipeline
just
with middleware components. Yes. Doesn't know anything about what kind of services in front of it.
Yeah, so very cool. The only thing that's custom is this. Yeah. The rest is the same. So it's I've got in my application, I've got a controller. There's nothing specific about files here, right?
We'll just get the request and start handling it.
Yes. So there's my normal one, there's my JSON one, there's my image one. Hence the get methods or the roots there. So let's hope that everything is working fine. I just want to quickly check if this thing is running. One thing to point out that if you're running.
Now listening on folder. How cool is that?
It's listening on folder because my implementation is literally, I'm giving a location, it's a location feature or something. You implement that and you say this is a folder path. Wow. And then you can do stuff like that because technically it's not a port, it's a folder. Cool. And that's what you see, right? Nice. So it's running there. And what I'm actually going to be doing, I will be trying to maybe do that and do that, for instance. Get that guy out of the way and just do a bit of cleanup here. So it's running, right? Oops. Yep. Now, technically, if I drop this file in there, it does stuff, right? So it ran through your pipeline. You see all these logs say it ran through. There's another demo that works, and I must move the folder. And then the third one. That also works, or that gives the exception. For some reason, it's still a bit wonky, but you get the idea. Yeah. So when you open up this response, you would have expected that the response is the response you would have gotten from the controller. Oh, nice. And the same goes for the JSON part. JSON one. Wow. So this is the idea where you switch out servers, how you want it to be working, and this is really easy. Like I said, the source code is on GitHub. Go check it out and go play with it. Nice. Yeah. I've also got another demo. Also one of the demos I've done. Are you guys familiar with model binding on MVC? So this is what makes MVC great. Is because you can give it a request based on certain convention. It knows that this payload is part of that object, and sort of magically have you to sort of work with strongly typed objects, which is great, right?
And you can get stuff from the body or from the query string or
from
the route.
Yes, actually in 2.1 they've switched around from the previous versions like 2.0. They had the when you do a request to an endpoint, you almost always for posts you have to say from body. For a complex type. But they've switched it around now in 2.1 to infer that, because if you're doing a post and you're expecting a complex object, it's 99% of the time it's from the body.
It's never on the query string.
Exactly. So you don't have to put it in now, but it works other way around now. So if you really wanted to grab it from the query string, you explicitly need to put it in there now, like the query string. But that's just lesser code to write, right? That's cool. So just going back to the demo of model binding, for instance, here I have a normal controller that accepts.
I don't know if it's so normal with an emotional photo VTL.
No, it's just a type, right?
Look at it as a normal post that expecting a strongly typed thing, right? That it's the same as I would have gone into Postman and send in this JSON, for instance. Don't really much look at this one. It's not really needed, but guys, this is the one it's a collection of scores. Each one has a key and a score, right?
Okay, right.
And then what we want to do, what we want to achieve is we don't want our controller to do any kind of business logic depending on the mapping.
Yeah.
Right? We want something to map it for us.
Yeah.
Right? Think of AutoMapper or something to hand us the bounded model based on certain inputs. But my problem is, I want to be posting an image. I think this guy is famous by now because he's in all my posts. But I want to be posting this image from Postman or from a REST line, and it must know that this image has these scores of emotions.
Yeah.
So to do that, normally we would have done that logic in the controller, which messes up our controller, and you know, it's not clean.
Yeah.
So another way of solving this problem is by utilizing a model binder, and this is how you set up model. But one of the ways you can set up model binders in ASP.NET is by just having this attribute model binder.
You register it on a type.
Yes, on the type. You can also register it globally by like a type of T thingy, but this is the easiest, I would say.
Yeah.
And then if we go there, it has implementation of iModel binder. All right, and the iModel binder has one function called bind async. So just without further ado, I'm just going to show you the demo. Right, so this base64 is a representation of the image I'm posting. As you can see, there's WebKit form boundaries and stuff like that. This is the image, trust me. Right, so sending this request will probably, without that special binding thing, will give a nullable object because it's not expecting byte array per se. It's expecting an object with byte array inside. It's expecting a JSON object.
And is this the entire picture with all the pictures of the guy, or is one? You can see, because here is the one where he got his mouth open.
This is one picture.
It's in there. You can see it.
I see.
That's the second one from the top left.
I see. Yeah. So this is the same as posting the image manually, right?
Yeah.
So hopefully, if I send this request there, I should get back a response of my
DTO.
DTO.
Oh, wow.
My implementation was, for this case, I forgot to mention that, I just echo back my scores. Right, just for the effect. But the idea is, whenever I send a request, it goes from bytes to something that maps the emotion to my DTO, which is this.
And then you can do your business logic because you're not interested in getting these scores. You
exactly. Yes. So for this example, I chose to use Azure, you know, the Face API to intercept. My model binder uses the Azure client, so the Face API client. It grabs the photo out of the bounding context, one of the properties. It parses it as base64. Then I call my get emotion result async, passing my subscription key, which opens up a HTTP client. I know this is a very naughty way of doing things, but just bear with me.
It's a demo.
Exactly. So this goes to cognitive services, gets basically the emotion result, but that might be different from what I expect. So here I just convert that back to a emotion result object, which entails map it back here and gives my bounding context result, the actual object that's bound to this to this result here. So in a case when you're running, you can feel warm and fuzzy about whatever you will get here will be filled with data, given that it was a base64 thing, because it goes from image to model to a emotional detail.
It's really a clean separation. It's nice.
I'm all about clean code, and the more and more you can get stuff out of the code into separate areas of
single responsibilities.
Exactly. And ASP.NET Core is very, very good of offering that flexibility. You could do still the same way, but you know, we tend to be clean programmers, right? Clean code and stuff, and I like the way this is set up.
Pretty cool.
Very cool. Yeah. So I know you did prepare some other demos for your talk you did this morning. Those are on your GitHub page, so people can find them.
Yeah, so I have a GitHub page. Don't laugh at my profile. I believe it is github.com/Fanie Reynders. Like I have on internet. So there's my GitHub page, and there should be Let's see, there's beer.
Beer.
That's just to show that there is no a true representation of your commits. So if you go to my repositories page, you should be getting the ASP.NET Core Hidden Gems repository, which should be there, and I should be able to have the slide deck also up and running.
Yeah,
there.
we'll put the link also in the description.
Yeah.
Cool. Thanks so much.
Yeah.
Thank you.
And thank you for watching, and we'll hope to see you next time.
Yes.
Thanks.
Bye bye.
Bye bye.